This is lesson 2.2, explore ratio and proportion in right triangles, found on page 29 in your workbook. When we look at right triangles, we can actually label sides other than hypotenuse as adjacent side and the opposite side. When you label these two sides, what you need to first do is to fix an angle in a triangle. So let's take a look at the diagram in example 1. Here you're given triangle ABC. Notice how angle A has been marked with an angle marker. So this is our fixed angle. So to locate the adjacent side, we have to go to the leg, which is right next to the fixed angle right here. So side AB is the adjacent side of triangle ABC. So let's mark this as adjacent. And then to locate the opposite side, you have to go to the fixed angle A. Imagine you're pointing an arrow across away from angle A. You're looking at side BC. So this is known as the opposite side. Well, the remaining side is the one that you should be familiar with. This is the longest side right across from the right angle at B. So side AC is the hypotenuse of this right triangle. So having learned about the adjacent side and the opposite side, let's use the following 4 triangles to practice labeling the hypotenuse, the opposite, and the adjacent sides. We will start with A, triangle M and O. First, let's find the hypotenuse, which is the side right across from angle N, the right angle. Side MO is the hypotenuse. Now, the fixed angle, according to the drawing, is angle M. So, imagine you have an arrow pointing away from angle M. You're looking at side NO. This is called the opposite side, which means the remaining side must be the adjacent side. Let's check it. This is a side that is not the hypotenuse nor the opposite side, and is right next to or adjacent to angle M. And here is our label. Now take a look at triangle B, or triangle PQR. The fixed angle is at angle P. I will let you think about which side you will label as the hypotenuse. Remember where the right angle is. Did you pick side PR? And now let's try to find the opposite side. Find angle P, the marked angle, right across from angle P. That's side QR. And finally, the adjacent side is P and Q. So this is very similar to your first example. How about triangle SUT? Where is the hypotenuse? This side UT. Now your fixed angle is T, which is at the bottom here. So try to imagine drawing an arrow across. Side SU becomes the opposite side. And then side ST is the adjacent side. Take a look at triangle WVX. Which side will you label as the hypotenuse? Is it this side, side VW? Where is the fixed angle? It's angle V. Therefore, side WX will be the opposite side, and VX is the adjacent side. Now let's move on to example 2. Let's find the ratio comparing side lengths. Given triangle GHJ, write the ratio comparing the length of the side opposite angle G to the length of the hypotenuse. Then express the ratio as decimal, rounded to 3 decimal places. Alright, so angle G is the top angle here. And if you read the question carefully, you will see that, let me get my highlighter, the two sides that we are interested in are the opposite side and the hypotenuse. So sometimes it's a good idea to highlight these keywords in the question to help you focus. Okay, so now let's find these two sides. This side is your hypotenuse because it's right across from the right angle H. And then the opposite side from angle G is side HJ. So let's label this as the opposite side. Alright, so now it's time to write the ratio. We would like to find this ratio of opposite over hypotenuse, which is equal to, so now we can substitute the length of these two sides. Opposite side is 4.4 centimeters, and then the hypotenuse is 8.5 centimeters. And now let me draw in the fraction lines. We are also asked to express this ratio as a decimal. So now take out your calculator and try to figure out what 4.4 divided by 8.5 is. I got 0.518 approximately. So let's put a dot above the equal sign. And that's it. That's example 2. Later on in this chapter, we'll learn more about these ratios comparing side lengths in triangles and how they're useful in finding the other missing angles or any missing sides in a triangle. Let's turn the page. You're going to find a lot of practice questions on this page. To get you started, I'm going to do number 1 with you. Number 1, write a ratio comparing the length of the side opposite the marked angle to the length of the hypotenuse. Then express the ratio as a decimal, rounded to 3 decimal places. So this is very similar to the last question that we have done. Once again, I will highly recommend that you highlight the keywords in the question. I see the word opposite and hypotenuse. Here is your marked angle S. Where is your opposite side? Let's mark that. And where is your hypotenuse? Let's mark this too. And then let's express this as a ratio. So your opposite side is side KY. Your hypotenuse is side SY. And this is equal to, we sub in the numbers now, KY is 5.8 and hypotenuse is, or SY is 10.4. Okay, so let's do this properly. So here is the fraction line. Alright. And then punch into your calculator the rounded answer of 5.8 divided by 10.4. What does this give you? I think you will get this number, approximately. So here is your lesson 2.2. Now continue to work on the rest of the questions in this section. So finish number 2, 3, 4, 5 on this page, and also the next page in your workbook.